Hi. I'm Amelia Amon. I'm a solar and wind designer out of New York City. And thank you all for coming to this enlightening but slightly controversial talk. We've had a lot of discussion about this before when we were organizing it, and it promises to be really exceptional. I wanted to begin with some words from the British sci-fi writer and futurist Arthur C. Clarke. Formulated his 3 laws of prediction of the future. When a distinguished but elderly scientist states that something is possible, he is almost certainly right. When he states that something is impossible, he is probably wrong. 2, the only way of discovering the limits of the possible is to venture a little way past them into the impossible. And 3, any sufficiently advanced technology is indistinguishable from magic. And so with that, I want to introduce our 2 experts in their fields and instigators and organizers of this session. Henry McLean, AIA Lead AP, is an architect, educator, and principal of Timeless Architecture. Actively promoting green design in the Northeast since 1987, he currently teaches with the Sustainable Design Institute at the Boston Architectural College and serves on the Milton, Mass. Alternative Energy Committee. And next is Ambrose Spencer, who's a building and systems technician, author, lecturer, environmental design instructor, and founding board member of Quantal Energy. He is an independent researcher in energy infrastructure, efficiency and rental property, community wind, and special lighting. As an involved volunteer with NESEA for 30 years, he is our go-to expert for sustainable technology and philosophy. And if you have any questions about that, ask or anything else, ask Ambrose. Okay, thank you.
Thank you, Amelia. Welcome, everyone. It's a pleasure to be here. We owe a debt of gratitude to Amelia and to Jamie Wolf for supporting this session from day one, and we're happy to, actually very honored to be here with Dr. Theodore Loder and Jim Dunn, who've been pioneering this work of emerging technologies for the last 20 years or more. This is a NESEA session. It's AIA credit. You've all seen this slide. We just want to make sure you know you're in the right room. And I'll just give you the session overview and then talk about our learning objectives for the session and move right along. Solar, wind, hydro, and biofuels are proven renewable energy technologies. But are there other game-changing technologies emerging that minimize fuel emissions and harmful waste? Controversial new energy technologies include advanced ultra-high efficiency motors, energetic plasma, electromagnetic field devices, and low-energy nuclear reaction systems, LENR. Some of these employ reactions between atoms not yet fully modeled by conventional physics. Learn today how these new systems, as well as new low-cost water treatment, can be commercialized. And over the next 10 to 25 years, these systems may provide wide-scale, emission-free, low-cost sources of heat, AC, water, power, and steam. So the learning objectives, which is part of the process for doing a workshop in this conference, are the following. And it's to comprehend the range of emerging renewable technologies that will help speed up the growing transition off of fossil fuels and reduce the impending threats of climate change. Understanding how emerging systems now being fully developed and tested are demonstrating energy production with many orders of magnitude greater than conventional fossil fuels with no adverse environmental effects. And 3 is to review examples of these new technologies in the area of water, hydrogen energy sources, magnetics and motors, interesting physics, and the use of earth energies. And finally, to review examples of companies now using some of these technologies available now and on display here in booth 907 set up by Jim Dunn. And Jim will be talking a lot more about those. So just a slide to sort of put this in the context of whole systems in action thinking. This is an overlay of the USGBC LEED components and the Living Building Challenge, which you all heard about this morning. And both can be seen as whole system flow diagrams leading to win-win opportunities. We'll be talking or the speakers will be covering a lot of ground on the issues of energy, water, and materials. But certainly, as part of this whole system thinking, they're all interconnected in our day-to-day. And finally, I just want to end with this slide. This is a few charts that started some of the online discussion that got going last summer that led up to this session. And the first one from the U.S. Department of Energy Sources and Uses, shows basically that our current energy flows leave us with about 55% lost energy on a daily basis. And then the chart below from Amory Lovins in a wonderful book called Reinventing Fire starts looking at how we're going to transition over the next 40 years to a world without carbon. The new challenge is to forecast the wedges to get us to 2050. And with that, I'd like to introduce my colleague, Ambrose Spencer, I'm very proud to be working with. Ambrose?
Thank you, Henry. I haven't spoken at one of these for a while. Over
Speak
here,
right in, Bruce.
over here, these are the methods that we can use to reduce the load. And these are the sources that we're using now, declining over time. This transition slide shows the 80% CO2 reduction in 40 years. James Hansen, atmospheric scientist, said that in his CO2 target paper that we should aim at reducing by 80% in 25 years or less. So this should actually be coming down like that. In order to prevent the need for more severe adaptation, any safe method with the possibility or potential of helping us should be developed. This is a list of the technologies that will be covered. Buildings need heat, cooling, electrical power, and water. The physics of low-energy nuclear reactions, otherwise known as lattice-assisted nuclear reaction and cold fusion, has been described by conventional quantum mechanics by Peter Hagelstein and others. Cold fusion and battery chargers are the furthest along. Cold fusion can be used as a boiler or for combined heat and power or cogeneration. Brown's gas is a new form of fuel. The solar system optimizer actually boosts photovoltaic power. As the solar industry grows, this could become a part of new systems, or be retrofitted to existing systems. Thank you. Environmental problems include challenges of water quality and water quantity, which climate change makes worse. These technologies and I don't have to read this to you in the interest of time. These three technologies, which will be described by the speakers, can assist in the solution of these problems. Lighting and drives can be more than half of building energy. These new kinds of motors are capable of large reductions in needed power. And a new type of lighting runs on water, seawater or urine, This will be described. This is particularly useful in the developing world. Back to you, Henry.
I'm just going to cue up Ted's talk and not that one. So, thank you all for your patience. Theodore C. Loder, PhD, is Professor Emeritus in the Department of Earth Sciences at the University of New Hampshire, where he taught classes in the field of chemical oceanography. Dr. Loder has testified before the U.S. Senate Environment and Public Works Committee on breakthrough technologies and their critical role concerning environmental trends in the energy crisis, available at this link. Dr. Loder is co-author of the disclosure briefing document made available to a press conference at the National Press Club on May 9th, 2001. He also co-authored the document, A Summary of Breakthrough to Energy Technologies, sent to President Obama in 2009, this link here. It's with great honor that we introduce and welcome Ted to Boston and NESEA. Thank you. Ted.
Playing with technology here. Good afternoon, everybody. I'm going to go pretty fast and cover a lot of interesting topics here. Part of my goal will be to give you some historical perspective on zero-point or free energy technologies. Go through the historical perspective, then go into some kind of really off-the-wall technologies and end up with some stuff you can buy today that's using earth energies, zero-point energies, or whatever else. So we're not talking, and so we'll go through the whole thing in about 30 minutes here. The outline for the first, this part, I'm part A, Jim Dunn will be speaking as part B when I'm done, but I'm going to review the concepts in the history of free energy, present ideas and reasons for suppression, because I often get the questions, why aren't we using this today? If it's been around, we'll go into that briefly. I'll provide sources for further study, review examples of new technologies, as I noted earlier, and then finally provide examples of various companies doing this sort of things. Now, the first thing that I want to talk about is what are transformational or disruptive technologies. And this is in a sort of as you can see, I've kind of listed areas, 3 categories: warfare, transportation, energy sources. And we can start off with how things develop. First of all, people fought each other with fists and rocks, and then spears, arrows, guns, planes, plain old bombs, atomic bombs, hydrogen bombs, neutron bombs, better, bigger ways of killing each other. And then there are things that are red or green or orange, are kind of things that are kind of out there. You may or may not be aware of these. For example, psychotronics, the use of mind-altering technologies, been around since the 30s or 40s. You may have never even heard of it. Take a look at it. Weather modifications. The Air Force say, hey, we're going to own the weather by the 2020s. They're doing it today. Another story, scalar wave technology. Tesla talked about this sort of thing, as are a lot of other physicists. We'll go into that, examples of how that's used later on. Transportation issues. We start off with feet. Still use feet a lot. Beast of burden. Horses, the Travis. If you don't know what that is, look it up. Wheels, steam engines, petrol engines, airplanes, rockets, boats, sailboats, powered boats, anti-gravity, teleportation, stargates are things that we talk about in science fiction. The anti-gravity technologies exist. We won't go into that today. I don't know about teleportation and stargates. Watch your local science fiction program. Energy sources, and here's where we are today for mostly. We start off with the basics. When that's all you got, sun and snuggling, move on to wood, source of heat energy, water power, wind power, coal power, whale oil, gas, nuclear reactions, water, hydroxy reactions using hydrogen and hydroxy. We'll talk about that briefly. Magnets, special uses of magnets. And then we get into extracting energy from the quantum vacuum state, the quote, free energy issue, and we'll talk about that more. Radiant energy, that's how Tesla described this. Earth energies are also stuff that Tesla worked on, as did others. So that's sort of the general outline of what that is. Now, I also quote Clark. This should be up there a little bit. this chap right here, you can't read his name here, but it doesn't matter, noted that any truth passes through 3 stages. First, it's ridiculed. Second, it's violently opposed. Third, it's accepted as self-evident. And we're kind of, in this area of energy technology, we're kind of sitting in this area right here. Now, Arthur Clarke rephrased this, to quote Arthur Clarke again, as we were introduced a few minutes ago, it's nonsense, it's not important. I always said it was a good idea, and then I thought of it first. So scientists who, anyway, you get the idea. So energy technologies, or research in energy technologies, is not something we started last year or even 10, 20 years ago. Nathan Stubblefield in the late 1800s, and this is a group of luminaries, in 1902 demonstrated an Earth magnetic induction wireless telephone in the 1880s and was patented. He was able to extract heat and power from the Earth, although called an Earth battery. By many, he called it an energy receiver, receptive cell for receiving Earth energies, converting them into something useful, and actually heating, creating heat and light with these energies. So this sort of technology has been around for a long time. Nikola Tesla, the genius of the probably end of the 19th century, the beginning of the 20th century, is the one who developed alternating current that we use today. We have our present society is thankful to Nikola Tesla, and he did a lot of other things. Some pictures of him. Finally, the public is going to be having a chance to find out more about his life with the movie that is coming out soon, Fragments from Olympus, the vision of Nikola Tesla, with usual love affairs and all sorts of conspiracy things and all sorts. Anyway, it's coming to a theater near you. One of the things he's most well known for is the development and building of the Wardenclyffe Tower, which was thought to be able to be used to transmit power wirelessly throughout the world. And so people wouldn't have to have wires coming to their house or whatever else. Now, interestingly enough, Jim McCanney, a scientist in this area, suggested also could extract energy from the Earth's vertical electrical field. I'll talk about how that works in a second, to actually obtain free energy. J.P. Morgan, who was funding Tesla, decided that no way was he going to fund somebody who would come up with free energy so he couldn't charge for it, because J.P. Morgan had generation plants and everything else, and so he kiboshed Tesla's work. How this might work, according to Jim McCanney, you build this tower, you crank in a hell of a lot of voltage into it, a couple 100,000 volts in the tower here. It aligns the atoms or the molecules in the atmosphere, plus negative, up and down, and actually bores a hole up through the atmosphere so that there's literally a channel for energy to come in from the upper ionosphere particles right down into the thing, and then could be distributed to energy. So it's still a controversial thing. Now, where do you find out about this sort of stuff? Tom Bearden has written a book, almost 950 some pages, which is really dense, with literally 400, 500, 700 references in it. If you really want to get into it, this is a good place to go. And it corrects the flawed laws of physics. We'll talk about that in a moment. What happened is, in the late 1800s, Lorentz removed the possibility of free energy as a source in Maxwell's equations. Everybody's heard of Maxwell. At least the Beatles sang about him. But Maxwell in 1865 really described how electromagnetic fields operate and everything else. But in 1892, Lorentz took the same Maxwell equations, rewrote them in a different format, and threw out the part of the equations that included the free energy aspect of energy. And for the last 4 to 5 generations of electrical engineers trained at luminary places such as MIT and everything else have used these corrected equations without the 0-point energy field included in them. So that's one of the reasons why our society and world is where it is today. Bearden notes in his writing that all electrical magnetic energy comes freely from the seething virtual state of the vacuum. And he suggests that by setting up a dipole, which is separation of charges, negative and positive, and holding them apart for a period of time, free energy flows in from the vacuum state into that, and if you can keep them apart, you can actually capture that energy. So this is one of the sources of energy. It's from the ether, it's from the quantum vacuum state described by physicists as far as early as Dirac and others. It's been called by many people, all these things: cold energy, scalar wave energy, energy from the vacuum, zero-point field, dark or negative energy, longitudinal energy. Tesla called it radiant energy. In the 30s, Paul Dirac, a very well-known physicist at the time, described a way to extract this energy by inducing a negative energy probability in a local vacuum of a specific region. One simply introduces sharp, little low energy perturbations, bloop, 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 with sharp gradients, and the pulses pop out electrons from the Dirac sea, which is this sea of energy. So this has been described in physics for, that was in the 30s, so for 80 years or more. We've known about this thing. Well, is this stuff real? Well, this is Carl Fosness, a colleague of mine, and he's showing how radiant energy might work. What you see is here, he's holding, this is a copper rod, very high power is coming in, it's going through a spark gap here, and this is the situation with the radiant energy turned on. And he is actually holding a light bulb, which is brightly glowing between these two copper rods with his fingers. So it's not your normal 110 voltage, or he would be lying on the floor. It's radiant energy that he's extracting from the normal energy field. It's that stuff that Maxwell knew about and was taken out by Lorentz. So that's sort of an example of what it might be. Now, I talk about free energy, and I drew this cartoon, so you may laugh right now and get that over with, showing an idea about how it might work. Free energy, it kind of depends on the system boundaries. Everybody says it's impossible, or it's perpetual motion, or whatever else. Well, let me submit to you that perhaps there's a hydropower plant, if you didn't recognize it. Water's flowing in front of the mountains, blah, blah, blah. It's flowing in here, and it's flowing out into the ocean, and inside there's generators and turbines, and they make electricity, and the power goes out. If we look at the dotted box here, this looks like free energy. Water comes in from somewhere, water flows out, and we get power out of it. Well, if we know, if you step back and look at the bigger picture, actually, we know how it works. The sun, Mr. Sun up here, is evaporating the water. It goes up in the mountains and clouds, rains down, flows down. So the sun is driving the thing. So depending on how big your box is, you could say it's free energy, but we know how it works with the bigger thing. The same goes true with extracting energy from the quantum vacuum state. You're pulling it out, but it's all around us. It's like this giant river is flowing by you, and you're just pulling the water out of it, and the water keeps flowing by. So that's a little background to sort of try to conceptualize it. Now, people ask me constantly, if this stuff is real, how come we aren't using it today? And I have to really spend a couple minutes talking about what is called suppression. Even Dilbert, as you can see here, if I invented something, would you give me unlimited power? The Dogbird says, would you kill me in my sleep so you can steal it? Oh, of course not. Good. I mean, why would I wait until you were asleep? That's just burning daylight. In fact, I think I'm killing you right now just in case you already invented it and you're trying to decide whether you should tell me. It was a hypothetical question. Maybe, but it's not a chance I'm willing to take. So even Dilbert has sort of discussed this sort of issue. Is quote, suppression real? You're darn tootin' it is. And let me give you a couple examples. How many of you are aware of Section 181 of the patent law? Okay, 2 people. Good. The rest of you now know about it. Section 181 of the U.S. patent law, this is real, you can look it up, states, and I'm going to read it because it's so important, whenever publication or disclosure by the publication of an application or grant of patent on an invention in which the government has proprietary interest might, in the opinion of the head of the interested government agency, be detrimental to the national security. That's a pretty broad brush, as we know. The Commissioner of Patents, upon being such notified, shall order the invention be kept secret, shall withhold the publication of the application of the grant, therefore under the blah, 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 blah. In other words, if our security state decides that something you've just invented that's going to save our toast in the morning is against national security, they can take that patent from you and fine you if you talk about it again. You're screwed. Now, do they do this? Do they use this? Yes, they sure do. Steve Aftergood, just a couple years ago, wrote back in 2010, at that time there were 5,135 inventions that were under secrecy orders at the end of fiscal 2010. 5,000 patents, and a lot of these include what we're talking about. So this is real stuff, has been suppressed. Under the Secrecy Act of 1951, Patent Applications Secrecy Order, we just talked about that. Now, a fellow named Gary Vestman put together back in 2007 examples of suppression cases. I'm not going to read this to you, obviously, but he found 95 suppressed incidents that he discovered, people missing, 20 inventors associated threatened with death, 5, but all this is documented. And who was doing it? You name a government agency, and in some case, there were 59 of them involved in it, as well as the Canadians. Over 5,000 patents, we just talked about that, suppressed, classified secret. Companies involved in suppression of some sort, it goes on and on and on. Name your company. How they suppress this stuff is multiple by acquisition of technical, by front companies and then shelving the data, denial of patents, we've talked about that, seizure or suppression of the technology, and national security interest. And most of these illegal actions are by rogue, unsupervised entities. Now, there's people with their own agenda sort of take the law into their own hands, and there are multiple more, just goes on and on and on, how it's done and how this stuff is taken away from inventors. And I've talked personally to a number of inventors, as has my colleague Jim Dunn. Now, why? And I'm just going to have a couple slides about why, because it's so important to understand why. Why? If we have these technologies, why aren't we using it for the betterment of the world? The knowledge relating to energy phenomena must have such a great potential for changing the status quo that its continued suppression is deemed essential at all costs. That's why 5,000 or more have been sequestered. The basic physics behind energy generation propulsion system could easily replace existing energy generation propulsion systems, and with them entire geopolitical and economic order. Remember, to be non-politically correct, for the most part, the white guys between Russia, Europe, and the United States kind of run the first world in terms of energy use and everything else. And so the third world, second world, would like to have some of this technology which they could have. Remember, those people in control, and we see this happening today on the news every day between Russia and the United States and Europe and EU. All those in control like to stay in control. They are risk adverse, do not like significant change, do not give up control and power easily. The changes would be immense and sudden. There would be no need for oil, gas, coal, nuclear power plants, or an internal combustion engine, no pollution, if these technologies would be allowed to bloom and be available to people. It's not going to happen overnight. The knowledge would happen overnight, but the use of it would take 20 years or more. Where do you get information on these things? There's a number of books. I'm just going to show these pictures of them. Coming in by Gene Manning, Lost Science by Gary Vassiliadis, Quest for Zero Point, Tom Vallone's book, he was going to be the speaker today, Free Energy books by Bearden, and then Breakthrough Power book right here, if you want to look at a copy, is there. Brown's gas technology is one of those technologies that's available today. It's known as hydroxy gas or whatever else, and it's a mixture of hydrogen and oxygen in a 2-to-1 ratio. You take oxygen, you electrolyze it, you pop water. You electrolyze it, you pop out oxygen and H2, and then you bring it back together and you burn it, giving off heat and energy. Different electrolyzers produce different mixtures of stuff, and so the resulting Brown's gas has more energy than what you put into it. Where does it come from? Still a matter of major debate. This Brown's gas is rather interesting because there's some anomalies. It has a cool flame, and yet it will melt and vaporize tungsten when it's burning. 6,000 degrees plus. The flame can alter radioactivity. think about what I just said. It can alter radioactivity. There may be extra electrons in it. Not sure how it all works. There's still a lot of debate about where Brown's gas gets its extra energy from, but it's a real phenomena. Maybe from plasma charged clusters, it's thought. Microscopic ball lightning, Ken Shoulder's work, you'll see later in a minute, talks about that. Hydrogen action may be extracting energy from the ether. I'll talk about that in a minute, etc. Stan Myers had a very efficient way of breaking water apart. Here he is working on things. Here is his water-powered car that was on TV and everything else back when. And what he did, this is one of his experimental devices I photographed. We are running it here. What he did, he put out frequencies of energy into water which oscillated very, very rapidly and essentially shook the water molecules apart using less energy than Faraday's constant of breaking them apart using normal electrolysis. There's a number of sources on this, and if you get the video afterwards, you can go look these up. I'm not going to go through them to find out more about them. William Line, back a little while ago, had a theory about how this might work, and he suggested that hydrogen molecule, H2, that's the molecule, H2, when it breaks apart into hydrogen and hydrogen, monatomic atoms of hydrogen, that it then, the electron cloud around the hydrogen atom would expand because they're now alone and pull in energy from the ether field or the background. The hydrogen atom would now have pulled in energy so that when it then was reunited, that energy would be given off. So that was one theory that how this might work and might explain why cold fusion works. Because in cold fusion, you're doing something with hydrogen and you're getting excess energy out of it. Don't know. There are a lot of theories about cold fusion. Jim will talk about it in a few minutes. Magnetic energies are another area. Bearden and there's a lot of information on that available to people on it. And they talk about what Dirac talked about, i.e. Putting negative energy in, causing pulses, and the dipole. And strong gradients are known to disobey the second law of thermodynamics, so that you get this spike and what have you, and negative energy comes in from the quantum vacuum state. They've also developed magnetic devices, such as the MEG, the magnetic energy generator, in that you have a set of magnets in a system which you oscillate coils around them. The magnets respond, come back with a shock, and actually produce more energy than we put into them. They've had a lot of trouble with, they've produced a coefficient of power multiple times. In other words, more power out than in, using the power of the magnets. Magnacoaster, a company that I've been involved with for about 6 years now, and these are pictures of the fellow developing it, Richard Willis, and one of his earlier coils has extremely strong neodymium magnets surrounded by coils. They hit these magnets with a certain frequency. It depresses the magnetic field. Then you release that, and the magnetic field comes back, boom, and then don't forget, you produce electricity by putting a magnetic field around through a coil. So a generator works by a coil magnetic field. And this is one of his devices. Power, if pulsed into coils in the right format, can remove magnetic windings, and then the field will return, causing higher voltage. They've spent about 6 years working on this. Literally, here they are testing, and finally, according to which they're actually starting to ship. And we can't wait to get our hands on one of these things, because this actually produces more power out than in. That would be cool. And the power then goes into batteries, which condition them. Charge clusters, another source of producing charge clusters, produce little donuts of energy, toroids of energy, which can actually melt holes right through glass and aluminum foil, etc. Another source of energy, not quite well understood, but is something to researching on. Ball lightning. Those little guys, those little toroids, are a version of ball lightning. This is chucking off in his system, his creating ball lightning inside there. I remember standing by that and getting quite a UV burn, not realizing the thing was putting out so much UV. Why did I get burned on one side, not the other? Anyway, that's his work. He's now moved to Bulgaria. People at MIT are also working on ball lightning. These are a couple people there and some of their examples. This is one of their devices there. They have toroids in left and right, colliding them, creating a version of fusion, which is the ball lightning. The goal with ball lightning is that it extracts energy from the quantum vacuum state in some way, but how to capture it and then use it and actually be able to use something to do something with. The Casimir effect is another physics thing which has to do with there is energy between two plates held very, very close together. DARPA thought enough of this to put $10 million into research in that area, and we're still waiting to hear just whether their $10 million has been spent well or not. Thane Hines up in Canada has been working for years with magnetic motors. Started out with earlier stuff. This is pictures I took of him a number of years ago, 5 or 6 years ago. Different motors, different motors, different motors. And he's working on magnetic motors, trying to capture the back EMF that drives a motor and then reuse that back EMF instead of losing it. Now, products that you might be able to see in the near future or can see in the future today. William Alec, Bill Alec, has a little company that is producing a self-charging scooter. Here they claim, notice that they claim, I haven't seen one of these yet, they claim that by August they'll be producing a device, puts out 250 watts constantly. By plugging into a battery, it uses a little bit of energy in the battery to play this game of creating more energy, extracting energy from the Dirac sea. Remember we talked about that earlier? So they seem to, if the technology is as he claims, and I put that thing on it, then they have sort of broken the code and somehow to get that energy. We'll see. Kepi Motors, out in our display booth at 907, there's some information. This is a company that has developed a resonant magnetic mechanical motor. Picture of one right here. They can be used in fans and what have you. They claim up to 10 times more efficient motor than prior art. If you look at some of their graphs, this is their motor, this is conventional motors in terms of watts versus RPM, in terms of using a small motor or a fan or whatever else. If you look at their technology and you look at their speed and compared to Energy Star criteria, they're at high speed almost 3 times more than Energy Star, low speed 6 times more than Energy Star. If you look at the Kepi motor technology and compare it to another of other fans, and by the way, when you look at power and efficiency of different companies, it is often bogus. I actually redid the math on some of these people that people have published, and it was wrong. For example, these guys claimed 219 as their efficiency, and it turned out it was a lot less. This is watts per cubic foot per minute, 280 watts. Excuse me, 280 cubic feet per minute per watt. There we go. So it turns out that Kepi at their medium speed is the most efficient fan going. And this is, the Hunter fan is what I bought for my house 10 years ago from Home Depot. Okay, this is their information. If you want more information on this, you can pick up some brochures here or at our booth 907. They will be manufactured and available sometime later this spring.
And see a kit that isn't built yet.
And okay, water treatment is another area that you can buy today. There's also brochures on that. And what these people have done, and I helped with the development of this, they use something called template-assisted crystallization. And they actually have these beads that form crystals on them, calcium, magnesium, what have you, bicarbonate, and then washes down so you no longer need all of the salt removal techniques, the normal water softening. It just takes these stuff out and the crystals go down the drain, and it's available in sizes ranging up to 900 gallons a minute. Major hotels are starting to use it because it's so effective and so cheap. The last technology I'm going to show you is probably some of the most interesting. The people from Aquapol, I got them here. They have developed about 20-some years ago, William Mulhern, absolute genius, has a patented energy converting device used to demoisturize damp buildings without the use of external energy. No batteries, no plug-in. It uses the Earth's field of energy, Earth force field, to collect zero-point energy, and then it then puts out energy fields that literally push the water back out of the basement. It's used, they've sold over 50,000 units in Europe to date. Over 50,000 units. So this is a going concern. The people here, they're just starting to make these available in the United States. If you've got a damp basement and you want to look into this, you may want to consider this, or anybody working with buildings with that sort of thing. Finally, you can't read it very well. I will skip that SOS. The point is the rest of the world is racing by the United States. We need to support more of this research in the United States. Thank you.
Jim Dunn is president of Energy Technology Consultants and Future Solar Energy Systems. He's past directors of the NASA New England Regional Tech Transfer Center and later the Center for Technology Commercialization. He has experience in due diligence and new venture startups in a wide variety of technologies. His education is Worcester Polytechnic. He's co-founder of a Worcester Polytechnic Venture Forum, which provides programs, advice, and networking to entrepreneurs, investors. Jim has written many papers and presented often on a wide variety of subjects: energy storage, renewable energy, hybrid vehicles. Is a volunteer with the Northeast Sustainable Energy Association for 10 years, in the Tour de Sol, which was an over-the-road environmental car contest. And he holds a number of patents and had a project to develop a fuel cell-powered aircraft. Please welcome Jim Dunn.
All right, if you thought Ted was going fast, I'm going to go twice the speed. Because my job is to show you that some of these technologies are available today, and that you're going to see devices in the top 3 of the 6 primary categories of supporting life. Energy is, we talked about heat, power, and transportation. Water, which is the lifeblood of humanity, becoming an even worse problem than oil. Peak water is coming soon. And shelter, of course, we're going to talk about how we can build enough homes at an incredibly low price that are self-powered, that don't need water or sewer. So let's just start out talking. These are the things I'm going to talk about in a minute, but we're going to talk about a new industrial motor technology that is the biggest breakthrough I've seen in about 20 years. And as Ted said, he and I, between us, have reviewed over 150 of these breakthrough technologies. Unfortunately, there weren't that many that did what the inventor claimed they're supposed to. So we're going to talk to you about a motor that is going to rewrite the history books, because when we always thought that a horsepower was 746 watts, you're going to learn that it's less than 400 coming. Also, new energy storage technologies that break the code on cost, way below $200 a kilowatt hour, which is the DOE target. And then also a new device right here that is going to allow you to take any solar system, particularly ones that have been installed for a long period of time, and boost the output by 20 to 25%. And then we're also going to, in addition to talking about the things above, we're going to go into a little bit about what's going on in the LE&R field, the low energy nuclear reactors. And then we're going to talk about water with this technology. If you look over here, this is the first time that's been exposed to the public. This is the world's most advanced water treatment technology, developed right up in Tewksbury, Massachusetts. And this is going to revolutionize the water field, producing water for less than $2 a 1,000 gallons. Pure water using a vapor distillation system. And so that's basically it. The last thing, as I said, we're going to talk about a way to build a home using structural insulated panels and all these other technologies we're talking about that will not use any power, will not need to be connected to water or sewer, totally self-supported for under $20,000, and can be built almost anywhere. All right, I'm going to start out with the convergent power motor, and this is the motor I was telling you that, I don't know whether you can all hear me there or not. Is that better? Okay, so this is an amazing toroid type motor, and this is twice as efficient as any normal motor today. And we think of motors being very efficient. We have motors up in the high 90% efficiency. The only thing is those motors, for every amount of energy that produces forward torque, has what's called a back electromotive force that acts like a brake. And what this group has done is come up with a way to not only eliminate the back EMF, but to capture it and redirect it in the forward motion. And I won't go through all the areas where we use motors. And by the way, when Ted was showing the Kepi motor, that is a fractional horsepower motor, about a 1/25th of a horsepower. And it can be scaled up maybe into the 5, 10, 20 horsepower area. We're talking about industrial motors here that could be 100 to 1,000 horsepower or bigger. It's a huge market, and this market alone represents 45% of the electricity consumed across the planet. And that's actually growing now because of all the electric cars, which also use electric motors. So this is a major area. And these motors, because they're going to cost a little bit more than a traditional motor because they have a very advanced control system. But the annual savings is going to be about $18,000 to $20,000 a year per motor. And so the payback time is less than 7 months. And over 5 years, the savings could be $90,000 to $100,000 just for a 100 horsepower motor, which is not that big. And as I was saying earlier, what they've done, but what we're talking about is instead of the generator being coupled to the motor and the back EMF of the generator slowing down the motor, requiring more power, this gentleman has separated the generator from the motor. He's applied for 12 or 13 patents. He's already received 5 or 6. This is a major breakthrough. And I think when you start seeing this apply to industrial applications, HVACs, a lot of industrial motors and large machine shops and industrial machines, this is going to be very significant. And the beautiful part about this is normally efficiency peaks when the torque and RPM are both at their maximum. Here, the efficiency the efficiency of this is just the opposite. So on a normal motor, you have a peak point and then it starts dropping off. On this motor, it continues. I don't know why I can't get this thing on the screen. The efficiency and the torque continues to increase. It's a major departure. As you can see here, this is a crossover point between a typical DC motor and this motor where the torque continues to increase. As the torque increases and the efficiency actually goes up. That's what a typical, this is a demo motor that's about 3.5 to 5 horsepower. And, this, although it's still early in testing, NASA's just starting to test it right now to validate a lot of the claims on special dynos, but we should have some good reports in about 60 to 90 days on how this is emerging. And this is the inventor, Jim Murray, out in Oklahoma City. We're going to try and put together a summary of all the contacts for all of the companies and have a printout you can pick up at booth 907 tomorrow. All right, moving right along. You've all seen what's happening in the energy storage field with a lot of the new advanced batteries. A lot of the liquid batteries are being developed at MIT, and a lot of the advanced lithium-ion and other lithium polymer batteries. This is a battery being developed down in Edison, New Jersey, and their goal is to hit, Ted, are we running out of juice here? We need a better battery, I guess. The goal of this is to break the DOE goal of $200 per kilowatt hour. Right now we're in the $400 to $600 with lithium-ion. And they're now testing batteries with a number of the utilities and getting incredible results. This is designed initially for grid tie applications. And as you know, we have plenty of generating capability. We just don't have it running at the right mix at the right time. And particularly with wind turbines and solar coming on in Germany now, they have a major problem because they have areas where they have to pay people to turn on loads to take the power or shut down a lot of the wind turbines. And the nuclear, they can't shut down, the base load. So this is going to be a major change for a number of areas, and they're targeting lifetimes of 20 to 30 years, which for a zinc-based chemistry is unheard of. And a very high energy density, and this is something that's also going to be a safe chemistry. So this is a comparison to this based against lead acid, lithium ion, and sodium sulfur, and there's a number of other, those are conventional battery technologies, and then this is compressed air and pumped hydro, the two leading non-battery or non-chemical systems. And this is just a comparison. By achieving this low cost, that opens up all these additional markets of over 40 gigawatts of capacity versus currently about 4 gigawatts that are being addressed by lithium ion. I won't go through a lot of these other slides just for time, but you can go to their website and see a lot of this stuff. They are making major partnerships with a lot of the leading manufacturers of inverters and other equipment, and they will have systems out in test by the end of the year. They actually have a few right now. This is really a significant breakthrough. And this is what some of their modules look like. I'm trying to get them actually to give me some reject modules to use with some of these clustered housing projects we're doing in South America, which could be kind of interesting. And that's what, by the way, what's happening with a lot of the electric vehicle batteries now. They're being given a second, or there will be given a second life. We're still early in the life of those. Unfortunately, in the translation, a lot of these slides got clobbered here. But this is amazing that they would even think they could use this in an electric vehicle. They don't necessarily mean Chevy Volts like I drive, or Priuses or other cars. They typically are looking at buses and trucks and larger capacity systems. But it's amazing that that could already be a possibility. So look at EOS, and you can get on their website. Philippe would be glad to hear from any of you that would like to discuss new applications. Most of their systems are very big in the 1 to 20 megawatt. And this is an announcement that just came out last week of GE's liquid battery that they're targeting for electric vehicles as well. I just threw that in. Okay, now we're going to get into a very exciting technology, which is this box right here. And this is made by Ultrasolar. And that box, just by plugging it in between your panels and your inverter, it's about a 10-minute installation, that will boost any existing solar system by 20 to 25%. And they've shown me graphs of some cases where they've gotten as much as 36% improvement. Now you ask, how could this be possible? With all the things we've done with solar and improvements and enhancements and optimizers, this uses pyroelectricity, which is amazing. It's a device or a technology where they actually use a coated glass, and as the temperature changes of this glass that's inside this box, it produces a very high frequency signal up in the terahertz region, which is pretty high frequency, and that causes a reaction in the solar panels, backfeeding that signal up into the panels, where you're now getting a much higher emissions of kind of what we would think of as hot electrons, and almost, if you've heard of the case where we're now getting 2 electrons per photon with some of the new technologies, they're doing the same thing here, but it's more like a quantum well effect, where they're trapping more electrons in the system. These do work. They're going to be relatively low price, meaning in the 50 to 60 cents a watt, which is not much of an addition if you've already got a $8 or $10 a watt solar system that you've invested in the past. And as you know, solar systems typically drop off about 0.5% a year. But this shows the green part is the added boost, and a panel would normally degrade so that at the end of 20 years, you're only getting 80% of the power. Most of the panels today are guaranteed to give you 80% at the end of 25 years. This is just another example where you normally would overbuild the system. By using their approach with their added electronics, you wouldn't need as many panels to begin with. And this just shows you a comparison of the normal operation of a solar system to what you would get as the added output. And most of that is added current. You're not increasing the voltage that much, but you're dramatically spreading the window of optimizing the output of the system. If anyone's interested in talking about that more, I'll be down in the exhibit later today and tomorrow in 907, and we have literature and a lot of information about it. Okay, this is the box called the QB1500. This is limited to only 1500 watts, which today most of our strings are 2500 to 3000 or more watts, but they will have a higher voltage, higher headroom system coming out in probably August or September. This one will be on the market sometime in the second quarter. And that's one of the very first units. That's going to go to WPI for some testing here soon. That's the contact with Ultrasolar. Okay, this guy, he probably kind of a little comic a joke here about the old days with the DC-AC battle and the fact that people would not want to use it. Okay, this is the Hydrolite. Got one kicking around here somewhere. This is a water-powered flashlight, which is also going to be marketed. Thought I had one here. Anyway, we'll demo this later down in the booth. You have to put a little water and salt in it here, and or you can put urine in it. But it's basically the old Russian magnesium water, power cell that was used in a lot of the life vests and stuff, things like that. So this is just real quickly what they're hoping to do. They got away from batteries. They targeted this originally for a UN program for a system that would allow people to have a way to charge their cell phones as well as light up their huts without having, to use up any batteries or have a solar panel. And actually, it's kind of interesting that when they started developing these, they discovered that there's more people that have cell phones than that have power. You say, well, if people have all these cell phones, how do they charge them up? Well, in third world countries, people are walking 5 or 6 miles every second or third day to recharge their cell phones. It's kind of amazing. They don't have any power, or not even solar power there. So these use a little electrode, which is sort of a sacrificial, rod made out of magnesium. And the life of the rod, though, is significantly higher even than alkaline batteries versus standard AA batteries. And they have a large size rod for the bigger systems. So that's it's very easy. You remove the top, you fill it up with water, you add a little salt, close it up, and you got power. And this fellow, Ivan Kruglock, out in Colorado, was the contact for that. Okay, can you change my slides? Okay, all right, now I'm going to speed up. We're going to get into the exciting things. And Ambrose, can you pull that poster up a little bit so people can see it? So we're going to start by talking about this amazing breakthrough here with Aquabac Technologies, that they've been working on this technology for over 15 years. They've spent over $30 million, have over 25 patents and another 8 or 10 in process. I don't know whether we can get much light on that. But this is the full size. That's the exact size of the unit. There's one of the doers for this down in the exhibit 907. And this is done through a lot of interesting approaches. But basically, they have built this whole system inside a vacuum doer, so they recuperate 99% of the heat. So instead of taking, I thought we had fixed these. Instead of taking a typical 2,400 watt hours per gallon for a conventional distiller, they're only using 20 watt hours per gallon. So they can process typical 10 to 12 cent a kilowatt hour cost. They can process 1,000 gallons of water for less than $1. And actually, I've designed a solar system that will run this with 4 solar panels. This is a conventional system. This is nature's way of treating water. Unfortunately, that doesn't work fast enough for a lot of people. And this is the way they do it with the compressor and the condenser and evaporators built in with a very unique counterflow heat exchanger. So this is a traditional distillation system, and this is showing 2,400 watt hours per gallon. Remember, they're at 20 watt hours per gallon, and I've just seen some test data where they're running a few units at 18 watt hours per gallon. And compared to any of the normal filtration or reverse osmosis systems, if you have a filter failure, the dirty water contaminates the clean water, you got to tear down the whole system, purify it, and then start all over. There's fail-safe. There's no way that the dirty water can ever go in the clean side. It can only go from clean to dirty. This is a traditional diagram showing the counterflow heat exchangers and the rest of the system, including they have a little module they can add on, which will take all the solid waste and burn that and actually use that as added heat. These are all the different versions of the product. The basic unit, which is what this is called, the DRM module, which is about 480 gallons a day, can then be put in a series of cells of 24 into a pod and then up into a pack and then up to an E-pack, which has its own power system on it, and that would be used like for a municipal application. So this allows you to take a site, if any of you have ever had a problem with trying to put a septic in when the land won't perk, this is an ideal solution, or of a failed septic. And there's just in Long Island alone and down to the Cape, there's probably 300,000 or 400,000 failed septic systems where the homes are going to be condemned within 5 years. So this shows you, again, from the smallest systems all the way up to a large industrial commercial system. This is in case where they have a failed septic. They can add this system in, and very simple, low cost, and leave the existing tank and stuff, and just process everything directly with this little box. So there's a lot of other benefits here. The biggest benefit is to recycle water over and over again. Many of you know that we already have a number of countries that are reprocessing your waste today, and so the water you're drinking was yesterday's sewer, and this will allow you to do the same thing directly on site. And this is going to be a big problem. I designed a system using 2 of these back to back that we'll show you in a minute in this new world home. And this basically has 2 flash heaters, 1 for each side, and then the aquabac treatment that's shared with a waste tank on the bottom, a solid waste tank, and a fresh water tank. And you have to start by filling the fresh water tank with 1,000 gallons, and then you add the rainwater into the system, and in most cases you won't even have to, you might need to top it up once a year. And that's a top-down view. So that's the company, and if anyone's interested, you can stop by. We'll have lists of all the contacts tomorrow. Okay, this is my little baby, and I just got back from Colombia and in Peru, and the president of Colombia said he wants to build 100,000 of these on a test project. They have more than 3 million people that are homeless, and major housing problems. And they took me to show me their lowest cost homes. I should have put a picture in here because they would blow you away. These are high-rise poured concrete facilities. They have one light and 1 outlet per room. A 450 square foot house. You can get raw with no refinement, just the raw cement walls, no tile on the wall, 1 toilet and 1 little single burner gas stove with the gas connection for only $44,000 if you put 30% down and you wait about 1.5 years to get the house finished. And it's pretty crazy. But what we're looking at is a way to use a lot of different technologies, including this little wet water processing module. And again, these, I don't know why I'm having trouble here. This is 2 3-bedroom units back to back, and these are 2 2-bedroom units. And then these are built in clusters of 8. We're using a lot of new technologies, including a unique way to pour the concrete on the site with a special portable machine that makes 5 yards of concrete every minute. Very interesting, without having to have a mixing truck. A lot of other things that we're looking at, and using structural insulated panels, which are pretty common today in the U.S., including ones that have the outside skins made that they don't need to have any paint or any additional processing. Also, some high-efficiency lighting systems that are pre-wired into the walls. And then a new way to make interior walls, and we're trying to see about filling these to make them soundproof. But this is an extruded polystyrene material, comes up to 30 millimeters thick. We would also use it for the roof. But there's a lot of amazing things that can be done by pre-making a the interior walls with this, and also by making lofts. But this is a typical layout. Now this would be about 580 square feet, and the bathrooms will be made back to back. These are the SIPs. An example of those they're pretty lightweight. You can see Van panels down on the first floor. I think they're in exhibit 630. I'm getting out of whack here with the slides. With the special coatings that are actually a ceramic skin on them. They are fire resistant, and they offer you to deliver to the site with a varying wall thickness, all kinds of R-rated SIPs. The interior walls separating the bedrooms are made with this material, and a 15-inch wall now includes 3 closets in it. And then over the top of the bedrooms is the same material. Instead of a 5 to 6 inch thick floor, you've got a 1 inch thick material that can then make it into a loft for storage or for the kids. This is the machine that we tow to the site, and that blends all the materials and produces, I said, a continuous 5 yards of mixed concrete on the fly. It's made in Italy. The bathrooms I already talked about, and this is the heart of the water treatment is the Aquavac system here. We have a lot of other technologies that are included in that, but that basically gives you the idea. The kitchens are all pre-made, and that slide didn't come out too good there, but that's supposed to show you channels in the walls and the lighting. And this is all powered by a relatively small amount of solar, because they don't have a lot of things that take up a lot of power there. And in most cases, air conditioning is a luxury. But we use a small amount of air conditioning here to get rid of our excess power whenever we're not treating the water. These will be made in clusters of 8 with a little kind of alcove or patio in the middle. And then the roofs on this material go up in less than an hour with 3 sheets of material per house. So that's basically the home setup. The beauty of this is they can be built quickly, and of course they don't need any power, water, or sewer. And this is something that would be designed to also create a lot of jobs in the third world countries. Okay, now we're going to get into an area that I've spent a lot of time studying, which is an emerging area. How many of you here have heard of cold fusion? Okay, cold fusion happened back in 1989 with 2 scientists, Pons and Fleischmann. We replicated at MIT, but they were told not to publish the results, and led to a lot of controversy, and the scientists got kicked out of the United States because they were rejected by the physics community. They later went to Europe, and particularly in France, they replicated the technology, and the Europeans got on board, and most of the science today is in Europe, particularly Italy, Greece, and France, and a lot of work in Japan. But we now have devices running, but instead of using deuterium and palladium and platinum as we did originally, we now use nickel and hydrogen. A little bit of powdered nickel and 8 to 10 grams of hydrogen will run one of these reactors for 6 to 9 months, producing almost an infinite amount of heat. When we're all done, we end up with the same weight of materials, but now we have copper. We've transmuted the nickel to copper. Very interesting phenomena, and it's very, very small amount of materials. We have very little radioactive, no radioactive waste, but we do get a little radiation produced when we start the reactors up. But we now have a lot of these running, and ironically enough, now even the Department of Energy is jumping on board. By the way, we've calculated we're looking at energy densities that are 1 to 2,000 times the energy density of diesel fuel. And diesel fuel and gasoline are considered 2 of our more energetic fuels without looking at propellants that we use in rockets. So Andrea Rossi in Bologna, Italy, now he's here in the U.S., down in Raleigh, North Carolina, is one of the early players here with what he called the ECAT, the energy catalyst. And he has quite a few versions. We'll talk about that in a minute. Defcalion had originally partnered with him, and they were making the Hyperion as an OEM product. And they have been through a number of iterations, but they broke off with Rossi back about 2.5 years ago. Brilliant is a guy named Bob Godis out in California. He's been working with SRI. He has a very interesting system, but he's limited to a coefficient of performance of 2. He's getting twice the output of whatever his input energy is, where Rossi typically is getting about 6 and Defcalion claims up to 10. Blacklight Power, Randy Mills, he's raised more money than every other inventor in the field, over $85 million. He just recently announced a system with his hydrino theory where he demonstrated for about a millisecond a huge power gain. Unfortunately, he hasn't ever run one for more than not even a second. But he's down in Princeton. Nick Energy is a fellow named Francesco Piantelli. He has a lot of intellectual property, but he doesn't have any products. But he's just starting to work with powdered nickel, where he was working with solid nickel. And then George Miley up in Chicago, he has a company called Lanuco. And actually, again, this got reformatted and kicked off a lot of the, there were a few more inventors here. Celani, Francesco Celani over in Rome, and a lot of gentlemen over in Japan. And actually, the Russians have some very interesting systems, particularly plasma systems. I'm just about to review one that produces heat and electricity simultaneously, which is very interesting. Okay, this is anyhow, Rossi's recently been working with higher temperature units, and just recently, again, it got clipped off here, I think. Yep, okay. So his technology was bought by a company called Industrial Heat, which was created by Cherokee Investments. They're down in Raleigh, North Carolina, and they're doing a lot of independent third-party tests. A lot of Rossi's testing earlier was questioned because he had some of his own scientists involved, and he was involved in a lot of the tests. But they're going to publish a report sometime in April or May of all the independent third-party testing, and also they're looking to raise a significant amount of money to commercialize this. He was written up as an article on his black box by a gentleman that I helped a lot with a story that was out in November of 2012. They're going to do an update on that as soon as the new testing comes out. Defcalion started out in Greece. They've now moved to Vancouver. I've tested a lot of their reactors, and I've had NASA test a lot of them. They don't have too much of long run time, and they are bringing out a new reactor in about a month and a half or 2 months called the Gen 6 reactor. But they have a lot of OEMs that have been interested in licensing for certain countries that are paying pretty significant amounts of money to get on board. And again, most of the systems produce hot water. Some of them produce steam as well. But there's so many applications in the process heat field, and particularly in making cement. I had no idea how much cement heat it took. Okay, so been given the wrap it up story here. But the advantage of this is so mind-blowing, it's incredible. By the way, there's other things even coming still. I mean, Ted and I are unfortunately swamped with requests to go out and look at this stuff. But the intellectual property is a big issue, as well as the certification and compliance. But the biggest thing here is that this is going to create a whole new field of research. And this is going to really change the way we think about energy, particularly from heat and electricity. And that's the end of my talk. There is a colloquium coming up on the 21st at MIT. It's only $70. I encourage anyone who's interested to sign up for that. It'll be very worthwhile, and they'll meet a lot of there's about 35 or 40 of the primary inventors there. And then also, here's some websites. And I have to put in a plug for Infinite Energy Magazine, because Ted and I are on the board of the New Energy Foundation there. Okay, that's it.
What I wanted to ask you is,
She's got the mic.
I got the mic. No, I was asking you the first question. You see a lot of technologies, I guess, in what you know. Okay, so most of us are not physicists or scientists. How do we get a sense of what claims to believe, and how to
That's a tough one.
how to make sense of all this information that we're getting?
I'll try to answer that and let Jim answer it. It's very, very difficult. Jim and I both have had dozens of cases where an inventor has claimed X, Y, and Z. You actually go there to visit the claim, and the cat died, or something happened that day, and suddenly the device doesn't work. And this has happened dozens of times. And the only way you can do it is hope that there's independent verification. And,
Or testing.
and most of the time, the inventors are so freaked out by anybody playing with their baby that it's very difficult to wrestle the black box from the person and test it independently. They're their own worst enemy. And I'm not everyone, but it's very, very difficult. Jim?
Yeah, we have actually, Ted and I have to compare notes sometimes because sometimes we can appear to be fooled by an inventor who's so excited about something that he's many times misread the data, particularly on phase angle. Anyone who's putting out AC power, we find that they usually multiply the volts times the amps without taking into account the phase angle. So that's a common thing, but we also have a lot of inventors who have worked on things for so long they've actually deluded themselves. That they're actually seeing things that aren't there. And then, unfortunately, we have a lot of inventors that just don't have a clue. And I had one in South Africa about 3 or 4 years ago. I had to fly down there, 15-and-a-half-hour flight. And I said to the investors, whatever you do, don't give this guy another nickel till we get there. Well, they had just put another $800,000 into the investment, and the inventor was driving around a brand new Mercedes SUV, which was a bad sign. But the minute I got in the lab, I said, something's not right here. There were no carcasses. Ted and I can tell you, usually we have to sort of plot our way through like the pickers with all the previous ones that didn't work. And then there were no drawings, not even the back of napkins or nothing. So I knew something was up right away. And it turned out within an hour we found that he was scamming the investors. And there were 5 different cases where they all were the same, that he had, very unfortunate, but we do see that.
My favorite one was then there's the total scam. An example, we worked with somebody in Canada who had this device that was, for energy, making energy, whoopee, here's all the data, et cetera. Finally, our people went up there and looked at it. He actually had drilled a wire through the back of the device that was plugged into the wall. And it was feeding the device from the back of the, but you didn't see this when you looked at the device. It was sort of secretly hidden. Or sometimes they come up through a table leg. Anyway.
Great, thank you. Okay, I guess now we open it up to the floor.
Over there.
Microphone. This will be your question.
I have a question on
Just use it.
the water product, and are there any scaling problems at all?
Which one, the scaling product?
The water production?
Oh,
Water treatment system?
Yeah.
Yeah, they are not having scaling problems, but there are a lot of interesting aspects of the way the vapor distillation works, and they actually have some interesting ways to separate out any of the waste on the hot side as they're boiling the water. But fortunately, we have a solution if we need it, but that hasn't been a problem yet.
Okay, next, over here. Anybody else? How about Jamie, who's right there?
For any of you, does anyone have any observations or just comments on the so-called supercapacitors as storage devices?
Sure, yeah. Supercapacitors or ultracapacitors, depending on which category you're looking at, have been a pretty amazing phenomena, and in the U.S. they're used extensively on hybrid vehicles, particularly hybrid buses. They're unfortunately very expensive, and the energy density is quite low. They're about 8 watt-hours per kilogram, and volumetrically they're worse. So, and they're very expensive in the sense of applying on a large scale. But ultracaps are coming down, and when we start getting graphene-based systems, I think they'll be a lot more affordable. Maxwell is the leader in the U.S., followed by NESEA and Panasonic.
Okay, who's next?
Right here. Yeah, Jim, I'm quite fascinated with the TV amplifier system, we'll call it.
Right.
And a couple of things occur to me. One, it's a good thing there aren't many TV systems installed out there, so we won't really have to retrofit very many, especially the microinverters, which will be more costly per watt units to have to do that too. But it would seem they'd incorporate that into the inverter technology in general. That would be the way things will go in the future.
Yeah, there's a reason why that. Oh, okay, both. Okay,
This is
stereo.
recorded.
Okay, so
That's
So-
recording.
Oh, I see. Okay, all right. Okay. So the device has to be close to the panels. so that in the microinverter case, of course, it's on the back of the panel. But in most cases with regular inverters like Selectrias and SMAs and stuff, the inverter may be 50 or 100 feet or more from the panel. This has to be within 25 to 30 feet from the panel because of the terahertz signal that has to get back into the cells.
So that would push inverter manufacturers to have smaller inverters so they'd still be within 30 feet.
Well, possibly, yeah. You have to realize this is very, very new to the market. It'll be on the market in about a month and a half. I'm lucky that they trusted me with an early unit, although it's all sealed up, as you notice. But, ask me again in about 3 months.
Okay, next.
Oh, that's
Hi, I'm interested in converting power electric motors. I want to know, was it AC or DC, and what voltage is it running at? More specifications on that.
Okay, those motors could be made in any of a number of formats, and even up to ones that look like a switch reluctance motor, but most of them are multi-pole motors from 24 poles up and fairly large capacity. It could be applied to smaller motors, but if you think of it like a Chevy Volt that has like 130 horsepower drivetrain, that motor would be physically about the same, would just use half as much energy to accomplish the same distance or the same torque effect. It actually produces more torque, and in cases where you need the surge power or the higher torque, that would be a better choice.
Jim, I have a question on the housing and particularly the roof material. Is it fireproof and is it strong enough to make the stands that it needs to make?
Yeah, so let's take the spans first because you can make this up to 30 or 35 millimeters thick. You can drive literally a 2.5 ton truck over that with a 6-foot span. So you don't need the rafters, the typical 16 or 24 inch spacing. The other thing is it's fire resistant and fire retardant, and they may have to put a coating on it in some applications. In third world countries right now where we're targeting that, they don't have, their codes are important. They use the international kind of, codes, but more testing needs to be done on that to see if there might be some cases with extreme, it's more of an issue of the fumes that might be emitted, Yes, sir.
Question. We manufacture vertical axis drag style wind turbines. Question for you guys on storage.
Hold it closer to your.
We manufacture vertical axis drag style wind turbines, and the question is, what kind of recommendations would you have with the technologies you've been looking at for storage in remote locations?
Well, the EOS system, unfortunately, is only designed in large formats of a megawatt hour or larger. But otherwise, as far as energy storage, there are some smaller compressed air energy storage systems that might make sense because they have an augmentive turbine on the backside. So when you're compressing the air, you're making heat. And then at the other end, you want to get more expansion, into the expander to take the energy back out. But there is a company up in New Hampshire that's making some interesting devices you might want to look at. You remember the name of it? Okay, yep.
We got another person over here.
Just given the past history with the Patent Security Act that you talked about earlier, and then with new technologies coming, just curious, is there inventors cautious knowing the past history of this
Yes.
Act? And
Yes, sir.
have you seen yourself, inventions that went up for patent and disappeared?
The answer is sort of yes. The strategy that several inventors have used, in particular Ken Shoulders and Tom Bearden, was to publish a scientific article or a review article or whatever else on the whole technology the day they filed for their patent. So the technology was out there in the public, and it couldn't be sequestered by the patent because it was already out there. So you have to be clever, and those two guys, in terms of some of their technologies, were very clever. But I've talked to literally dozens of inventors who the biggest thing in the world was to get a patent on something, but they're going to be very quiet about it and not tell anybody. Well, that's the best way to be Section 181. and gone. By the way, I might mention that the Section 81, a lot of those patents are legitimately kept under wraps. Atomic secrets, for example, nuclear processing, nuclear bombs, that sort of thing. Fine, I have no problem with that at all. However, technologies that really are energy breakthroughs and could help all of us, I got a problem with.
My
Hang on. I want to interrupt briefly. If you're interested in what you've heard here today, I urge you to fill in your evaluation forms, which you were given when you walked into the room. It's the best way of guaranteeing that this topic will be covered in the future. Okay, go ahead, Drew.
Yeah, it's on, I can't feel myself. I'll just
Put it right up
project.
next to your mouth.
I'll just project, right?
Is it on?
It's on, it's got a thing that says it's on. Anyway, first of all, compliments to the session organizers. This session barely didn't make it for the conference, and they put in a lot of work to make it happen. And it's obviously been very, very nice. But the question that comes up,
Thank you.
is you guys have looked at 10 or 20 technologies here that are sort of in the, beyond the invention stage to the early development stages. The question to you is, with your sort of, you're ahead of us by 5 years view, what's the next 5 to 10 years of stuff ahead of the people you've shown us? Some examples out of that we might see coming.
Oh boy, good question. Yeah, like the crystal ball bit. Yeah. The crystal ball bit. Okay. The Aurora technology with self-charging scooters. If that's 6 months out, a year, maybe 5 years from now, it'll probably be refined and producing enough power to run your car. If the technology works as they say it will. It's going to take a while to spin up. The Magna Coaster technology, they've been working 6 years on it. They're basically starting to ship literally within the last couple months or now. So these things take a long time, and it's hard to tell. There's an interesting example of in the water treatment business. There's kind of leapfrog product. This product that Jim talked about is a leapfrog product. In other words, people were working with reverse osmosis and a bunch of other techniques. They just lost the race. If this works as claimed, then it certainly seems to.
I was out of the room, so I might have missed it, but the move 5 electrons with 1 photon technology. Anything heard in that front?
Well, we haven't seen more than 2 electrons per photon, so, but anyway, 5 would be good, but it would push us off the, that would be an over-unity device. And we're happy to just get it up into the, mid-20s for efficiency. Right now we're running 16 to 18% on most solar panels. But I'd like to say that I'm working on reviewing things now that even Ted hasn't seen yet, and which is kind of surprising. But anyway, well, either he or I always have to look at these. But anyway, one of these is a major, major breakthrough in the plasma area, and we're starting to see more and more plasma devices. And this one could be a very low cost, easier to implement, even easier than the LENR devices to control. And the other is something that is so mind-boggling that I'm having a hard time really coming to grips with it. It's a resonant energy device that could change the whole world. And right now it's being looked at for a special program in Detroit that would blow your minds if you saw it. But I can't say any more about it. I'll be testing these devices probably the end of this month. But everything I've seen so far is pretty mind-blowing. Unfortunately, as Ted was saying, we end up with a lot of situations with inventors who disappear on us. And I don't mean that they get wiped out or whatever, but they go quiet. And sometimes they're bought out. The technology is bought out, like Rossi recently, by an industrial heat. And other times they just get scared. And they get threatened and they leave the country. So then we have to go to Ecuador or some other place to track them down if we find them. But it's kind of sad that right now Ted and I are promoting going with open sourcing. And any inventor who's really worried about this, the best way is to publish it all over the internet, get devices all over the world, and that way, no matter what happens, no one can shut them down. And
Is this a fast one? 'Cause we got real quick.
Yep.
Just last question.
Thank you very much for coming. My co-chair,
Yeah, here.
Co-chair, Henry, would like to ask the last question.
Just wondering if you've had any feedback from the documents that you submitted to the Obama administration, the National Press Club, if you want to talk about that.
Yeah, we're pretty. We were asked by people when Obama went into office the first round to produce an energy document for him to talk about some of these technologies. We did that. At that time, we had a technology. Anyway, I won't go to that. But anyway, we did do that. We did submit a document. I co-wrote it with several other people, and we put that to the Obama administration. We know it got there. It got into the White House, but nothing happened. It's like falling into a black hole. That's all I can say.
Is that one of the new technologies?
Yeah, black holes are not a new technology.
You can give your feedback forms to me or to
We'll drop them off
I
on the
guess.
rail, whichever.
Thank you.